All right, so we just finished up with the range, and now we're going to talk about the domain for the secant graph. All right, so again, you see these asymptotes, so we need to identify them, and we need to first figure out when they're occurring. So if you see this is 1 pi over 2, the next one's going to be 3 pi over 2, and I know the next one would be 5 pi over 2. So this is very similar to the tan graph. It's actually the same exact domain. It's going to be every odd integer pi over 2, we're going to see a vertical asymptote. So our domain is going to be all real numbers except for, now the notation for an odd number we said is 2n minus 1 or 2n plus 1, however you remember it, pi over 2, and you have to include that n in our notation is an integer, so n equals z. All right, so that's our domain. That's how you write the domain of secant curve. Again, what are you responsible for knowing? Where those vertical asymptotes occur, okay? What the graph looks like, very, very similar to cosecant, except it's just shifted, and knowing your domain and your range. All right, so our last graph that we're going to look at is the cotangent graph, which is the reciprocal of your tan graph, of your tan of theta function. So we know cotangent of theta is 1 over tan theta. So again, I rather look at the tan graph that I'm comfortable with, but if you're not comfortable with the tan graph, easy enough to go to the unit circle, and instead of looking at knowing that tan of theta is sine over cosine, you're now going to pay attention that cotangent of theta is a reciprocal of that. It's cosine over sine. So here, cosine over sine is going to be 1 over 0, which is undefined. So I'm back to having an asymptote at 0. What I like to do is, if you're comfortable with the graphs, I'm going to go to a graph, and anywhere I see an x-intercept, which is here, 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 and here, I'm going to now draw vertical asymptotes there. Again, feel free to use the unit circle if you tend to understand that better. In AP Calc, we generally use a sine and the cosine curve, but we do use a unit circle for tan. So here, I'm just going to say, all right, my next asymptote was at pi, and the next one was at 2 pi. So I go ahead and draw those on my graph, like so. I'm sure you're thinking, exciting stuff. If you don't know my sarcasm. Okay, so those are my asymptotes. All right, the next piece that's different in this equation, in this graph, is the fact that I have an asymptote here at pi over 2. Well, if I have an asymptote at pi over 2, that means that this value was some number divided by 0. So now if I flip that, it's going to be 0 divided by a number. So if we want to just get a better understanding of that, we can look at the unit circle for cotangent of pi over 2. And here's pi over 2, and cotangent, I just said, was cosine over sine, which you see it's 0, and that number is 1. And so we know that 0 divided by 1, if your numerator is 0, then the entire fraction is equal to 0. So I know at pi over 2, it's 0. So what I tell kids is, listen, if your original function has an asymptote, it means that the denominator was 0. If you flip that, now the numerator is 0, and it makes the entire fraction equal 0. So therefore, I'm going to have another 0 value at 3 pi over 2, here, and here. Again, I don't have a curve. So now we're going to look at this graph, and I'm going to talk about the reciprocal. I'm saying if I want to flip a value between 0 and pi over 2, that we'll say is roughly 1, okay? It's going to stay 1. So that'll stay, if I call that 1 here. But this value, let's say, closer, is a half. And if I flip a half, it's now 2. So what you notice, I did that. That should have been at 45, that 1. Right? If at tan of 45 is 1 and the reciprocal at 45 is still 1. But closer, a value between 0 and 45, between 0 and 45, on the original graph is a half, so the reciprocal would be 2. So what you end up seeing is a curve that looks like this. Don't like what that just came out to be. It's going to be negative 1. Struggling with this pen today. And that's what our curve looks like. So if you're seeing the original function, these curves are going from left to right. It's increasing. The cotangent from left to right is decreasing. From left to right, decreasing. All right, and that is your cotangent graph, okay? And again, you're just responsible. This is a very, very minute detail that you might forget. So if that's the case, do go to the unit circle. Do remember that your value tan of 45 is 1, and if you flip 1, it stays 1, and that tan of 30 is roughly rad 3 over 3, which is going to be greater, which is a decimal, smaller than 1. So if I flip it, becomes a value greater than 1, and that's going to help you shape out that curve. Or you can just remember that your original function from left to right is increasing, so that's going to remind you that you're going to start low on the original function and go up, start low, go up, and that your reciprocal function is decreasing, okay? So however you want to remember it. All right, last but not least, we need to be able to identify the domain, and we notice that the domain, we have asymptotes at 0, at pi, at 2 pi. So I know my next asymptote is going to occur at 3 pi. So it's going to be at every integer pi. It's my vertical asymptotes. So how do I write that? It's all real numbers except for n pi, where n is an integer. That's your domain. My range, well, this one's nicer. If I look at my range, I'm looking at my y values. Does it ever stop going down, this function? Nope. And it doesn't ever stop going up. There's no gaps and holes on the y values. So therefore, my range is all real numbers. All right, so that's it. That's all you're responsible for. If you need to, rewatch this video, but the main pieces that you're responsible for is knowing the graph, knowing what it looks like, and identifying the domain and range for each reciprocal graph. And that's it. And then the next time when we meet in person, we will learn about inverse functions. Okay. I'm going to end that recording.